All right, so this lesson is going to be just focused on electron configurations some more and how we can abbreviate some of the really long ones. So I want you to get out your periodic table and we're going to take a look at some elements. And what I want you to do is figure out what is the electron configuration for that element. So as we take a look at lithium, lithium is number 3 on the periodic table. And so we're going to go with 3 electrons, and we can show that electron configuration as 1s2, 2s2, and so remember those subscripts need to add up to the total, so that's 3. Beryllium is the next element over, and so it's going to be 4. It's going to be 1s2, 2s2. All right, so what's after beryllium? After beryllium is boron, and then we move on to carbon, 6. And so now we're going to go 2, 2, and carbon is the second one in the second row of the p orbital, so it's 2p2. 2 plus 2 plus 2 equals 6. All right, so what do you think nitrogen's going to be? Well, it's the next one over, so it's going to be 2p3. Oxygen, next one over, 2p4. Then fluorine, what do you think that's going to be? It'll be 2p5. And the last one in that row is neon, 2p6. 2 plus 2 plus 6 is 10. As we move to sodium, you'll notice that now we drop down a row and we move into the third row, and sodium is the first element in the third row, and it's in the S block. So all we're adding between sodium and neon is this 3s1 here. So it's going to be exactly the same as neon is, but we're just adding a new piece. And so at a certain point, this is going to get longer and longer and longer, and there's a way we can abbreviate it and make it shorter. And that's what we're going to take a look at. So we're going to take all the parts that are the same, and we're simply going to add to it what's different, the 3s1. And the way we show that is that we go to the last element in that row before it. So the last element in the row before we get to sodium is neon. We say that that's the noble gas configuration because that column there is called the noble gases. We put a bracket, which is this symbol right here. We're going to put a bracket around neon, and we're just going to add what's new, 3s1. So sodium is going to be neon 3s1. That's how we would say it's abbreviated electron configuration. And by putting this neon in the brackets, we know by definition that it's this, which is the same for both of them. So that's a way we can abbreviate electron configurations and just focus on the outermost last electrons. Because ultimately, when we get into chemical reactions, only the outermost last electrons of an element are the ones that are important for chemical bonding. So as we look at aluminum, let's see if we can figure out what its abbreviated electron configuration is. So we're going to go to the last element in the row before it. We're going to go to that noble gas in the row before it. So as we look up, we're going to see that the electron configuration here represents that element neon, and we're going to just put what's in the row that aluminum has. And so it's going to be neon 3s2 3p1. That would be its abbreviated electron configuration. All right, let's do it with chlorine. What is the abbreviated electron configuration of chlorine? Again, the element is in the row before it is still neon, and we're going to just put what's on the row, 3s2, 3p5. It's the 7th one over in the row after neon. So we want to focus on just what we call the valence electrons. So that is what abbreviated electron configurations allow us to put our focus on, because the valence electrons are the only electrons that are actually used in chemical bonding. So valence electrons are the most important electrons, and they are the electrons in the outermost shell and the ones that are not completely full. These valence electrons are the only ones, the outermost electrons are the only ones that really matter when we talk about chemical bonding.